Welcome back to the Grand Solar Minimum channel. Today is Saturday, July 24th, 2021. Let's take a look at our current space weather conditions. Right now our solar wind speed's coming in at 318.8 kilometers per second with a density of 4.5. We are dealing with 4 sunspot regions, AR 28, 46, 47, 48, and 49. Those 4 will equal 46 sunspot numbers. And I put it on the 193 angstrom tonight for a couple of reasons. One, because I feel like that this angstrom does a good job at highlighting the brighter areas of the sun, especially sunspots. I feel like it does a better job. It brings out the spot a little bit better than the other angstroms. Actually, it makes it look a little brighter than what it is. And what I'm getting at here is I want people to kind of look back in 2016, 15, and 14 and look at the sunspots and the strength and how bright they were and how much they covered the sun. And take a look at what we're dealing with right now. Heading into a maximum in the next few years, 2024, 2025, somewhere in that vicinity. And we're trying to look for all kinds of different indicators as far as what is going to give us the signal that this cycle is going to be weak. And the one thing I've learned the most about this type of activity is in this research, time will tell. And it's so cliche, I know, but it's the truth. Time will tell. Right now, I feel like things are still pretty weak. Solar wind speeds are at 318.8 kilometers per second. What does that do to Earth's climate with low solar activity? And I'll tell you why we always blame low solar activity or blame weather on solar activity, lack of weak solar wind. That is reflected in our jet stream. And I'll go ahead and show you that here. When you have solar wind speeds that are as slow as that we're getting right now. Oh. It's good stuff here. Trying to switch here, folks. I don't know what is going on. Uh-oh. Mari, I might need you up here. Please. I'm having some technical difficulties here. And I don't know what is going on. So, Mari, if you're hearing this, please come up this way as we are experiencing some difficulty. Hang on a second. Maybe I can fix it with this. Briefly. All right, folks, bear with me here. It is see, it's not switching. There's another tab open somewhere. I can't find it.
Oh, well, let me have a look-see, little Jake.
Okay, so I was getting at lower solar wind speeds affecting Earth's climate. Thank you, Mari, very much. She's fixed it. And this is what I was talking about, the jet stream. Here's our handy dandy arrow. Here we are in the middle of the south right here. Look at the jet stream, folks. Look how high this is. And that's why we're seeing these heat domes in the north, across the central plains. This jet stream is usually somewhere across the middle of the country. When you have strong solar winds, you have a more straighter pattern of a jet stream. Guys, look at this jet stream. There is nothing straight or normal about this right now. It is all kinds out of whack. And that has a lot to do with slow solar wind speeds. I mean, it's just nuts over here. You wonder why we're seeing all this rainfall in crazy amounts in a short period of time. I mean, this is insane. The jet stream is all over the place, folks. Polar jet down here, of course, during the winter months of the... Some pretty intense stuff here at the top of the poles. Let's check that out. That's all the way up here in this angstrom. There we go. This is typical. It's winter down here, so you're going to see this. That's the South Pole. Nothing like that. Nothing like that up here, though, because it's not. Obviously, it's not winter. But solar wind speed affects the jet stream that brings us our weather. And right now, with those low solar wind speeds, we are experiencing some crazy weather patterns. And that is what is happening here, folks. So you can thank solar wind speed for that. Let's go over to the grandsolarminimum.com real quick. Check out some more space weather news. Actually, there was a CME to sideswipe. Well, that didn't happen. That's old news there. The C4 class solar flare here, you guys see. Let's zoom in on this. This was a long-lasting event. Usually they're a quick flash. A C class, it is Earth-facing. We will continue to monitor the situation if there's going to be any kind of geomagnetic impact from this. At this rate, we don't believe so. And C-class solar flares really don't do a whole lot of damage to really much of anything. Maybe some slight interference with GPS satellites and other things. Well, check out what's going on the sun right now. Very small sunspots, and quite frankly, you know, I said this last week. I still think there's a chance to sneak in a couple of spotless days. These sunspots are so small, folks. A sunspot number of 46 with 4 groupings. I don't even know why some of these are even being counted, honestly. Let me ask you, do you think this sunspot area would be counted? No. Probably not this one either. So when we're talking about the modern minimum and the sunspot numbers, you know, is it safe to say that maybe this one and this one's wiped off the board? Maybe. I don't know. Nonetheless, they're counting them, and they're small. And behind that, there's the eastern limb where my blue arrow is. Right this area is the backside beyond the eastern limb that has not yet pierced us. We are blank. Is there potential for these to decay and the sun to actually see a blank day? I'm telling you, it almost feels like the sun is flirting with us, that it wants to take a quick little nap before it starts get going again. I just have this little weird hunch. I don't know, I could be wrong, but it just keeps showing flashes that it wants to go back and do a little bit of a nap just for a few days and then snap back into it. But again, activity on the sun is pretty weak. Anything associated with sunspot activity, the weak ones anyway, maybe. 6.7 earthquake hits Mindoro, Philippines. This was yesterday. Strong earthquakes registered at a 6.7 at 2048 UTC on July 23rd, 2021. And it says it had a depth of 72 miles. The USGS is also reporting it at a 6.7, but a little bit shallower depth of 69 miles an hour, or 69 miles. And then the EMSC is reporting the earthquake at an M6.7 with a depth of 73 miles. So the consensus is this thing was at least 70 miles deep at 6.7. No major injuries or any tsunamis happened after that. And then today we had a 6.1, a shallow 6.1 in the Chromatic Islands region. Now this happened today about 12:51 UTC time. It was a depth of 6.8 miles, very, very shallow. The EMSC reported this at a 6.0, so weaker than yesterday's, but again, these are happening in areas that are appearing to not even cause any kind of action or damage or anything like that. No tsunami watches or warnings have been issued. In fact, let's take a look at the USGS before we move on from earthquakes. And you can see over the past several hours, we've had quite a few earthquakes across the region. Let's take a look at the West Coast. This was a 2.9, not that big of a deal, but again, it happened today, California. Another 2.6, California, happened today as well. This one was yesterday. This one is today. So we've got a moving east. Where is this one? This one is also today. So the one in Texas, I know, was also today. So interesting connection here as we see everything spreading out. But here's the problem. This was a 3.0 and this was a 2.6. This one is a 3.2. Is it possible that we could see another earthquake somewhere maybe near Tennessee at a 3.5 or higher? I don't know. We'll keep our eyes open and keep watch on this. Something to watch definitely, though. So a little bit of an uptick in some earthquake activity across the United States, but also across the globe as well. 2 strong earthquakes. And we've had some action from the sun, so that makes a little sense. We've had little tiny jolts to our magnetosphere, and that 6.1 would definitely be something of an effect from a tiny jolt. Heavy rain in Marsarata breaks a 40-year record for India. Listen to this. From July 1st to July 22nd, Ratnagiri recorded 77.1 inches of rain. The highest rainfall in 40 years, folks. Yeah, I said it. 77.1 inches of rain in 22 days. Their average is 38.2 inches of rain for the month of July. Aiden, please get Waylon. He's whining at my thing. Be quiet, too. So, we just talked about this the other night on the broadcast with China having its worst flood in 1,000 years, and it got 28 inches or 25 inches of rain in just 28 hours. But to get 3 times the average here, well, just about 2.5 times, I should say, the average of rain, and we're only at the 22nd day of July. What's causing all this rainfall? And we've been talking about it for many years now. Cosmic radiation, we are fluxed. And there's proof of that. And I want to show you guys something interesting too that has relations to this. But so we have heavy downpours here in India. And then we go to Turkey where they're experiencing flooding as well. Turkey Disaster and Emergency Management Authority said around 200 people have been evacuated after the Harvey River overflowed in the district of Harvey due to heavy rain. The district center, the village, roads, and province have been badly affected, cutting off access to dozens of villages. Not good situation over here. Trying to look for a amount of rain. There is no report here in this on how much we got, but you can see cars submerged into this deep water. Again, more flooding. Why is this happening? Again, July 22nd, we're talking about India, we're talking about Turkey. Last broadcast, it was China. You know, what is going on, right? Why are we seeing so much rainfall? And I keep talking about this cosmic radiation. So let's quickly go over that real quick. Cosmic radiation, aka highly charged particles, interact with particulates and water droplets already in the atmosphere. The cosmic radiation, the highly charged particles, serve as, let's just say, the glue and the steroids to these water droplets. So the more flux we are, the more likely that we're going to see bigger raindrops, increased amount of precipitation. Just depends on how much highly charged particles are already in the atmosphere. But remember, these highly charged particles are like magnets for water vapor, and they build and build and build and get big. Why am I mentioning this? Well, that's what's happening with these 77 inches of rain in 22 days. That's what's happening with these 24 inches of rain in 28 hours. That's how it's happening. Cosmic radiation. So I'm just kind of going through the Twitter today, and I found out that over in Dubai, the UAE, they are trying to change their rain averages and bring them up by cloud seeding. And of course, we've always talked about how geoengineering, a lot of people think it's a big thing, or man doesn't make that big of an impact on the climate. And I'm going to prove that right now, because this article does not prove man-made global warming or man-made climate change. The factors that go into cloud seeding here in this project in Dubai, the particles they are spraying into the cloud, and by the way, they have to be really picky about the cloud they pick. It's not just every cloud they get in the sky, they go send a drone out. They send a drone out, folks, not a plane, a drone. And this drone releases particles into the clouds. These particles mimic the same thing that cosmic radiation is doing in the atmosphere. They are basically bonding the particulates and the water vapor together to form these precipitation raindrops. Don't take it from me, it's in the video here, gentlemen here, this video here, how this cloud seeding works.
The UAE is one of the driest countries on Earth, with an annual rainfall of roughly 120 millimeters. As a result, it has to get creative when it comes to finding solutions for water. In the early 2000s, the UAE started performing regular cloud seeding operations. Cloud seeding is the process of increasing the amount of rain produced from clouds.
Some of these clouds, by nature, sometimes it rains, for example, only 40 to 50% of its rain that processed in the cloud that comes as rainfall. So by these operations, we try to increase this amount by, for example, from 15 to 30%.
So how does it work? It starts here, inside the National Center of Meteorology, where a team is constantly monitoring forecasts, looking for potential clouds to seed. The operations only work with cumulus clouds, which are vertical in shape.
Research 5 operation, can you read me?
Once they spot a cloud, they radio the pilots, who then take to the air armed with hydroscopic flares filled with a mixture of potassium chloride, sodium chloride, magnesium, and other materials. It's essentially salt. When the plane reaches the right clouds, the pilots release the flares.
These salts basically attracts the moisture.
Hear this now. The salts, these chemicals, basically attracts the moisture. Listen to what he says.
And try to make it condense. So these particles becomes nuclei of condensation. And then when these droplets condense, and then they hit each other, and then they form a bigger droplet that the air cannot hold it any longer in the air, so it forms as rain. So
folks, that is exactly how it works with cosmic radiation and highly charged particles. These, in this article, you're saying, well, I didn't see anything about highly charged particles in that video, but it does say that here in the article here, and I will find that for you, pointed out. Technology. Listen, the enhanced rain is created using drone technology that unleashes electrical charges into clouds in order for them to clump together and form precipitation. They are basically mimicking cosmic radiation, what highly charged particles do to certain clouds. That, to me, is showing you that they're not going up there with increased amounts of CO2 to get more rain. They're going up there with synthetic, highly charged particles to do the job of what cosmic rays are doing in most of the world right now. Unfortunately, the UAE is a dry part of the planet, always has been, always will be. Now, can this be done on a large scale? I don't see them saying this in confidence, no. They're only looking to increase the precipitation by 15 to 30% with this technology. So that tells you that it's not enough for even man to create a simulation of what cosmic radiation is capable of doing. So yes, they get more rain, but it's nowhere near like, it's like drinking Diet Pepsi and regular Pepsi, okay? There's no substitution in regular Pepsi, okay? Regular Pepsi is the cosmic rays. Diet Pepsi is the fake simulated charged particles. Nonetheless, this proves that man CO2 is not responsible for changing the weather or causing more precipitation or extreme weather. That they are simulating what happens already naturally in our climate. And they are proving the point that cosmic radiation, highly charged particles, are driving this so-called climate change, not CO2, not man. And the reason why there's so much of it in our atmosphere is because of the cycle that our sun is in, hence the grand solar minimum. Thank you, folks. I'll be here all week. Moving along here, hail and damaging winds pummel Chicagoland and the metro Detroit area. That's right, folks. Gust of winds, here we go, all the way from Nevada through the Plain States. This same storm system is now moving into South Carolina and the East Coast as we speak, or over the weekend it will be moving in. Hail fell across the region, including 2-inch in diameter in Shooks, Minnesota, 1.2-inch hail reported near Sorham, South Dakota. On Saturday, the dangerous weather began to move farther to the southeast, now making its way into Wisconsin, Michigan, weakening as they move into early Saturday evening. Of course, with the sun going down, we're losing energy and the storms get weaker. Imagine that. It's not because everyone turned their cars off and stopped emitting CO2 for the night. It's because the sun went down. It's providing a lot of energy to the storm system in the first place. Imagine that, sun driving climate. I just can't believe it. Through Saturday evening, here's where we're going to see torrential downpours, hail, isolated tornadoes, damaging wind gusts, and AccuWeather local StormX wind gust of 80 miles per hour. This system is scheduled to move on. Look at this. Michigan rainfall totals here in the past 36 hours. Look at Alaska, 3.42. Whitehall, Michigan, 3.4. Nothing nowhere near as impressive overseas, but still, that's usually about a month's worth of rain in most of these areas in just less than 2 days. So that's quite a bit of rain still. Yes, that's right. Cosmic radiation particles, highly charged particles, helping this cause here. Here's where that severe storms will be tomorrow afternoon, going across Scranton, Pennsylvania, all the way through the northeastern parts of Kentucky. So lots to watch here this weekend with severe weather. Hopefully not too terrible, but this cold front will continue to move eastward to finish out the weekend, bringing thunderstorms into places like Albany, New York, and Burlington, Vermont, a few which could be severe, which we've seen our share of storms out here. Speaking of CO2, what we were just talking about, not driving the climate, Mari had been in a discussion, and we actually touched base on this last week, talking about CO2, and I was laughing about how an admin was telling Mari that we do not get our CO2 readings from ice cores. Well, we do. But then one of our subscribers, Eli, I believe his name is, up in Michigan, I think the Wolverine state, I would say it's Michigan. But, oh, I said a bad word on the air, I'm sorry. Anyway, just kidding, Michigan. He made a comment in the section of that video and said to me that the accuracy of ice cores and CO2 readings are questionable only because we do not factor in the amount of pressure that is on these CO2 bubbles within these ice cores. So in other words, what we're looking at here is thousands of years of ice core information. And is it possible that this is actually 2 times the amount of CO2? Is it possible it's less? The problem with empirical data is that you got to know what the pressure was on these ice cores to really determine accurately what what the parts per million of CO2 actually was. Now, you noticed that starting here in the 1800s, and now this data only goes to 2016, which, to be fair, it's still rising, so it's not wrong right now, okay? It's still rising. The problem is that we are talking about having more accurate readings of CO2. In fact, I love here at the bottom where they try to debunk what I'm saying right now. And notice, guys, the article is written in dark black. And then the very bottom, in really hard to read print, I'm sure most of you are probably squinting right now at your phones or your PCs. But here in the notes section, where you're looking at what you thought that, you know, ice core samples are reliable when it comes to CO2. Here's what they say. CO2 measurements for the recent decades have come directly from air samples. So right now we're getting it from air samples. Measurements for the past centuries come from analysis of air trapped in bubbles in Antarctic ice. Each ice core is analyzed at multiple research facilities using multiple techniques. Because of this duplicate testing and the diversity of sampling methods, there is high confidence among scientists that ice core data accurately reflects CO2 levels in previous centuries. Why did they have to put this disclaimer at the bottom? Why did they put it in a different print? Because of what I'm telling you right now is why. There is no accuracy in ice core data dating back as far as 800,000 years, 600,000 years, 10,000 years, without knowing the type of pressure that those air bubbles are on inside those ice cores. Therefore, these numbers are just speculation and the best scientific guess they could give. My guess is that this right here was probably more closer to 300. My guess is this peak was probably a lot closer to the 400s and higher. Same with these. Because let's face it, folks, there is no way with the papers and the research that we've shown you, and you know that man emissions only count for 0.0004% of CO2 in the atmosphere. I've also brought you an article that shows that it is impossible for CO2 to trap heat at the surface because it only holds it for 0.0001 of a second. We've shown peer-reviewed papers that prove that. New research coming out daily. And now these cherry-picking graphs, these cherry-picking lazy AGW climate scientists that don't use accurate information, but they use these scare tactics. Look at all the CO2, oh my God. Yeah, that's because we are using ultra-sensitive equipment to measure the amount of CO2 in the atmosphere. Did we have that technology 400,000 years ago? No. So you're not going to get the same readings. Look, guys, we all know there's flaws in all kinds of scientific evidence, okay? And you have to factor for those things. So for someone to even use these charts as an example to prove to you that we're having man-made global warming is laughable. Next time you see this chart, laugh at it, because you know for the past 100 years the technology has only gotten better, and you know for the past thousands, hundreds of thousands of years that the technology was nowhere near what it is, and we can only speculate and give it our best educated guess based on what we have in front of us. Because there's no way to tell the pressure. There's really no accurate way to measure the CO2 in ice cores that date back 400, 500, 600,000 years and plus. Again, we're going to see this spike because we have ultra high sensitive equipment that measures better than anything ever before, ever. Don't believe the hype, folks. Look where it was before the industrial. This was normal. Right before we started getting the new technology, we were still right in normal waves of CO2 emissions. And the reason why it's skyrocketed straight up, like I said, improved technology. Here's an example of cherry picking the data. I want to show you This is NOAA's forecast map. They're talking about much above temperatures here in the northeast, especially in the corner up here. There will be some heat along the coast, but nowhere near above average or even slightly above average, in my opinion, for where I live. And I'll give you an example. GFS and NOAA aren't on the same page. Here is the next several days forecast for my neck of the woods, upstate New York. 79, 80, 83, 81, 75, 76, 75, 76, 75. Beautiful weather. 74, 72, 73. That's August 4th. The dog days of summer, right? And you're thinking to yourself, well, what's average? What's normal out there? I'll give you an example. For the month of July, we are usually somewhere around the 80-degree mark for the average temperature. Now, that doesn't mean we don't get up there, get high a few times, but the temperature in this area is supposed to be right around 78.4 degrees on the average for this time of year. And look at what we have. We have the next 4 days at just slightly above average, and then the next, the next 8 days, temperatures start at just below average slightly, and then starting into August, much below average, 4, 6 degrees even below average. So there's so much exaggeration when you see these colored maps. And you hear, obviously we're experiencing a lot of heat in the Northwest. That's, no crap Sherlock type mentality. Cooler weather across the South. They're saying hot, much hotter. There is a couple of days where we will see a 90-degree temperature here one day, an 87-degree temperature here one day. Nothing like a heat wave. For the most part, I just showed you how moderate that the weather is going to be. It's going to be below average, and yet there is in my area, according to NOAA, there is a 60% chance that temperatures will be much above average. And that's simply just not true. The narrative in the mainstream is always going to be the same. They are trying to tell you that we are warming, runaway global warming. What are we going to do? Oh my God. But yet, you look out your window and you see the opposite. So pay attention to stuff like that. Find out what your average temperatures are in your city. Find out what that is. Look at that information. Make your own decision. Average low temperatures for this time of year shouldn't go much below 58 degrees. August, 56. Believe it or not, I saw a couple 40s for the first week of August. Yeah. So I see below average temperatures coming. The last 11 days of this month typically aggregates around 1.22 inches. Add that to the 7.5 inches we already have for the month of July, and we're well above our monthly average. I think that's 3 times as high as well. Again, let's review what we talked about tonight real quick. Showed you the article about cloud seeding, and the technology they're using is the same as cosmic radiation. Highly charged particles. They're using synthetic highly charged particles, it says it in the article, to create downpours. Okay? CO2 graphs like this are a joke. Next time someone shows you this, laugh at them. Tell them that there is no accurate way of determining the CO2 concentration in these ice cores because of the type of pressure that some of these bubbles are under, and there's no real way of just accurately finding out what the parts per million actually was in these ice core bubbles. We only have a general idea. And the reason why we've seen the amount of CO2 skyrocket because we now have ultra-sensitive equipment. 2 earthquakes to talk about, the 6.1, the 6.7, No damages or tsunamis. Heavy rains thanks to cosmic radiation across the world. Once again, record-breaking rain. 77 inches of rain in India, folks, in just 22 days. That's almost 3 times the amount they get in a month. Let's check out the GFS forecast real quick. Several chances of rain here for us for the rest of July across the Northeast, the South. High pressure popping in and out across the Midwest and into the Northeast. But overall, folks, the pattern of rain in the Northeast, showers in the Northeast, that's going to happen off and on throughout the next several days. Minnesota, you're going to get rain. The problem is it's not going to be beneficial enough. You're going to get it scattered across central parts of Minnesota. Not entire parts of the state is going to get all this rain. In fact, I don't even see a really good shot of rain until August 5th, and that's on the eastern part of Minnesota. I'm watching that because I know the crops there are not doing as good as they should be. And notice all these rain systems that keep going north and into Canada from Minnesota. And I'll tell you why. It's that high pressure. See it right here? It's rotating everything clockwise, and it's pushing it up north above the border. And of course, Minnesota is in that protective dome that this high pressure is rotating the moisture this way. And you've noticed high pressure in and out most of the summer as well. And I think that's what's kept things wet. And I think, see, there's another example. Look at the size of this system. And that, thankfully, Minnesota, there is your first real substantial chance for rain, August 9th. That's not good news. I know farmers are very concerned right now. They've had a lot of heat. They haven't had a lot of rain in parts of the state. But this looks like your best chance. But if you're wondering in Wisconsin, you know, you need rain too, right? Well, you're going to get it as well. But the most of these storms, notice how they keep going north, northeast. This high pressure system down here off the coast of Maine is driving this clockwise and rotating this up north and pulling it away from us. But 5 chances of rain to come through Minnesota, all scattered, not enough really to make a difference until August 9th. Same for the Northeast and the South. More rain chances, at least 5 to 6 chances between now and the end of, or I'm sorry, the beginning of August. No hurricanes. The one that we were watching in the Gulf that was going to form over, I think this is the system by Tuesday. So as you see, it's just not organized enough, and I'll point it out with the arrow. This is where I think our low pressure system will be on Tuesday, that they were watching for development. And here's why we are not dealing with a hurricane right now. We are this storm is actually dealing with, and you guys can see it on the radar, but this is all dry air right here, and then there's wind shear, light, but there's wind shear in this area. So between the two mixtures, by the way, do you know why there's a lot of wind shear even present in this area right now? I'll tell you why. It's because of this pattern right here, La Nina. We're on a La Nina watch. We're already below baseline, and the light wind shear is just enough to help kind of take these storms down a notch or two, and that's what's happening right now. So high pressure dominating the Northeast, keeping things moist in the Northeast, parts of the Midwest, and across the South. Now, what about the Northwest, right? We need rain. Lots of rain. We've had monsoon flooding in Arizona, New Mexico. Those waves of showers continue all the way through the Rockies on the 28th. Finally, some light storms heading up in Montana, but this is where we start getting our first rain chances around August 1st for the northern plains of Minnesota, the Rockies, Wyoming, Montana by August 3rd. Still, folks, we need a ton of rain. Nevada, California, Oregon, Washington, and it is just bone dry, unfortunately, folks. And that is a typical GSM pattern, the dry, the hot, the drought. This is a typical regional experience during grand solar minimums. I know people are like, how? I thought grand solar minimum was ice age. No. Some grand solar minimums can be referred to a mini ice age, which brought colder temperatures than average. That's not what an ice age is. There's so many technicalities of that too. Here's what we're looking at today. Not bad weather. I'm sorry, this was Friday. Here's today. Pretty warm all across the United States, folks. Nice summer day. Everybody was in the 80s. Here's tomorrow, some storm action, bringing the temperatures down a little bit in the Northeast, but still pretty hot across the Central Plains and in the Northern Plains states, and the Southwest is always baking. But the Northeast and the Midwest, very comfortable. Some 80s throughout next week, And again, after that, there's a cold front that starts to move into the northeast and the Great Lakes near Ohio. You can see it right here on your map. Another high pressure system. But here, I'm going to show you what's really impressive as we get to August 3rd. Look at that. July 31st, forecasted lows near Albany is 49 degrees. Same with Rochester, 49 degrees. What do you think it's going to be a little bit further north and in the upper elevations here in the Adirondacks? Average temperatures for August, average at 58 degrees. So almost 10 degrees below average when you wake up on July 31st. That's Saturday. Temperatures do rebound pretty nicely into the mid-70s. Not bad. I'll take it. But look at the daytime highs in parts of Wisconsin, southern Minnesota, Illinois, Indiana, Ohio, for the most part. Not that warm, folks. These aren't beach days. More of the same on the 1st of August to 66 for a high in the capital region in New York. A little bit of heat returns on the 2nd of August into the 3rd, but more high pressure dominating the air. There's an 85-degree mark. And then I think we do get a 90-day out here too. So there's 2 hot days on the 5th and 6th of August in the Northeast. And then things start to taper down once again back to almost fall-like conditions in the Northeast by August 10th. Actually, 87 is not fall-like whatsoever. So it does look like that we are going to see somewhat of a summer, dog days of summer, in the second week of August for most of the country. Montana is the only state that actually is going to see a major cool down. Daytime highs temperatures at 52 degrees in Great Falls. So lots to watch, folks. Lots of headlines to keep up with. There's probably a lot of things that I missed that I wish I wouldn't have, but unfortunately there's just a lot going on, not just in my personal life, but around the world with climate, with space weather, with people taking off into space. It's crazy. I want to say hello to a few folks out there. Arnold Schmidt, knife collector, of course. Hello, sir. Shirley Davis, good to see you in the chat. Of course, hello to my lovely wife, Mari. Be nice to her, folks. Some new faces here. Jesse, good to see you, my friend, our farmer friend from Wisconsin. Lots of new faces in the chat as well. I saw Richard Davidson earlier. Good to see you as well, and as always, guys, if you like what we do, become a paid member here on YouTube, like $1.99 a month, or simply just visit our Teespring store. We've got t-shirts, coffee mugs, bumper stickers, you name it, we probably have it. And why do you buy t-shirts from this channel? Well, A, it helps support this channel, but B, it's a conversation piece. You're walking around town with your buddies, what the hell is GSM? You get to start dropping some seeds about natural climate change and solar cycles and how they can look it up for themselves. Don't give them the 3-hour documentary. Tell them to Google Grand Solar Minimum, Maunder Minimum. They'll get the picture. All right, that's going to do it for me tonight, folks. I hope everyone has a great and safe weekend. We will see you Monday morning with our next solar update here on the Grand Solar Minimum channel. Until then, we will talk soon.
Do you like this show? Give us a thumbs up. Want to support us more? Share to your favorite social media platform. Buy a t-shirt or become a Patreon. All links are in the description below.